Well, good evening, ladies and gentlemen. I'm David Barnforth. I'm a Vice President here at the Institution of Civil Engineers, and it's my really great pleasure this evening to welcome you all to the institution and to this fine lecture theatre, and also those joining us online to this its series, the 9th in the series of International Brunel Lectures. And the International Brunel Lectures, well, it was instituted in 1999 in memory of Isambard Kingdom Brunel and in recognition of his contribution to civil engineering. The 9th Brunel Lecture proposes that it's time for civil engineers to acknowledge the fundamental role that they play in reducing the vulnerability of mankind. And tonight's speaker, Joe Da Silva, will follow in the footsteps of Keith Clark, Peter Head and Paul Jowett, not just presenting a lecture here this evening, but taking it around the world. After tonight's presentation, we'll open the floor to questions, both for those of you here and those joining us online, and you're invited to join us in discussion. A few housekeeping notices before we start. First of all, the dreaded BlackBerry and mobile phone, if you could kindly ensure, please, that you have these either turned off or really turned to silent so that they don't interrupt the proceedings. And secondly, we're not planning any fire drills, so if the fire alarm goes off, and this is a warbling siren here in this lecture theatre, please go to the fire exits at the back of the room at either side, and you'll be guided to a safe exit by the 1 Great George Street staff. I'm really pleased that Joe accepted our invitation to do this prestigious Brunel Lecture Series this time round. Joe's a director at Arup, where she leads the Arup International Development, which she founded in 2007. Having studied engineering at Cambridge University, she began her career working in central India before joining Arup as a graduate engineer in 1989. Her subsequent experience as both a chartered civil and structural engineer includes working on significant projects such as Cheng Lap Kok Airport in Hong Kong, as well as the design of numerous educational, cultural and community facilities and various urban regeneration projects both in the developed and the developing world. Joe's interest in post-disaster context began in 1991 when she became a member of REDAR, a non-governmental agency providing training and technical expertise after major disasters. She has provided engineering expertise to service refugee camps during the Rwanda genocide, shelter advice following Hurricane Mitch in 1998, and she coordinated the construction of 60,000 shelters in Sri Lanka following the 2004 Indian Ocean tsunami. As a recognized expert in post-disaster shelter and reconstruction, she has authored various publications, including Lessons from Aceh, Key Considerations in Post-Disaster Reconstruction, and Engineering and Disaster Resource Partnership, a new public-private partnership model for disaster response. Over recent years, Joe has established Arup International Development as a not-for-profit business within the Arup Group, and is working in partnership with humanitarian and development organisations, including the Rockefeller Foundation, UNOPS, Habitat for Humanity, Oxfam, the Aga Khan Development Network, and the International Federation of the Red Cross, providing strategic advice and technical expertise to help realise the sustainable and resilient communities required to meet today's global challenges of rapid urbanisation, the uncertainty of climate change and widespread poverty. Joe currently sits on the grants panel of the Humanitarian Innovation Fund and the International Development Policy and Practice panel at the Institution of Civil Engineers. She also lectures at the Centre for Sustainable Development at the University of Cambridge, and in 2009 she was elected a Fellow of the Royal Academy of Engineering, and last year she received an OBE for services to engineering and to humanitarian relief. Tonight, she's going to talk to us about shifting agendas from response to resilience. Please join me in welcoming Joe Da Silva.
Good evening, ladies and gentlemen, members of the institution, distinguished guests. It's a great honour to have been invited to deliver this, the 9th Brunel Lecture. I thank you all for attending this evening, and I'm sure that Sophia, Brunel's sister, who herself would have been an engineer given the opportunity, would be very pleased to see a woman on this podium. Brunel's name has come to embody engineering achievement and ingenuity. He recognised that innovation involved risk, and his work epitomises the challenge engineers face, providing the infrastructure that enables socio-economic development, whilst also ensuring public safety. He faced numerous challenges and a few disasters, but didn't have to contend with the risks posed by natural hazards, such as earthquakes, flooding, or cyclones. In fact, in the 19th century, Victorian engineers such as Brunel viewed nature as a resource to be harnessed and redirected for the convenience of mankind, overlooking the fact that, of course, nature is a finite resource and also a mighty force with the ability to decimate communities. This photo is of Riga, a town in Aceh that was all but destroyed by the Indian Ocean tsunami. The community there were determined to rebuild their lives, and 18 months later, there are signs of recovery. A satellite dish, washing on the line, new houses. The topic of my lecture is natural disasters. Its title is intended to emphasize the need for a proactive approach to disaster risk reduction, one that is focused on creating resilient communities that are able to recover and adapt to changing circumstances and unexpected catastrophes, and also resilient cities that can continue to support their populations even when disasters strike. I've divided the lecture into 4 sections, starting with a sort of general introduction on the landscape of disaster risk, going on to talk about the future challenges posed by urbanization and climate change, which I believe are going to create a paradigm shift in how we approach disasters, and ending with my suggestions as to how engineers might consider disaster risk reduction in the future. Natural disasters are the consequences of events triggered by natural hazards. Volcanic eruptions, earthquakes, drought, floods, landslides, and cyclones may be viewed as acts of God. But as Ban Ki-moon rightly noted, their consequences, whether or not they result in disasters, are a result of mankind's actions. Each year, natural disasters cause significant death, damage, destruction, and human suffering. Overall, they affected 2 billion people over the last decade and resulted in losses averaging $100 billion a year. That's equivalent to the first bailout package for Greece or the annual infrastructure budget in Africa. Earthquakes are without doubt the deadliest hazard, and it's collapsed buildings that are responsible for the majority of deaths. Sadly, there are villages, towns, and cities in seismic areas throughout the world which are disasters waiting to happen, unless buildings are retrofitted and safer building practices introduced. And this includes many of our major cities. Building codes and standards have reduced earthquake mortality rates in higher income countries such as Japan and the US, but elsewhere, as in Haiti, codes of practice do not exist, are out of date, or not enforced. Construction quality is very poor, and the vast majority of structures are non-engineered. Almost 300,000 people died in Haiti as a result of the magnitude 7 earthquake on the 12th of January. A month later, the death toll due to the much larger magnitude 8.8 earthquake was less than 1,000. The difference was that in Chile, building codes had been introduced in the 60s following a devastating earthquake and had been rigorously enforced. In Haiti, the last significant earthquake was in 1842 and long forgotten. Ironically, there were a lot of NGOs and UN agencies carrying out disaster risk reduction programs in Haiti, but they were focused on hurricanes, which was a much more frequent, though much less catastrophic, event. Weather-related disasters, floods, storms, heat waves, drought, affect the greatest number of people, and floods alone affected 1 billion people over the last decade. a year. This graph clearly shows that disasters due to weather-related hazards are increasing. Their impact is exacerbated by environmental degradation and urban development. Higher rainfall and higher temperatures due to climate change are certainly contributing to more flooding, drought, heat waves, and changes in vector-borne diseases, even though the evidence that climate change is increasing the intensity of cyclones and tropical storms is not yet conclusive. It was the impact of natural disasters on hard-won development gains that resulted in the 1990s being declared the International Decade for Disaster Risk Reduction by the UN. Today, it's the rising cost of disasters that are causing concern for governments and the insurance industry alike. The Japanese earthquake and tsunami resulted in losses in excess of $200 billion, making it the most costly disaster event in history. Meanwhile, the flooding in Thailand last year affected global supply chains, which has put natural disasters on the agenda for major businesses. Toyota's car production, which is reliant on components made in Bangkok, slowed in several countries, including Venezuela, and the global cost of hard drives increased by 10%. Wealthy countries, like Japan, are, however, able to recover quickly, as losses represent only a small proportion of their GDP, and they have governments who are able to act. In contrast, in Haiti, the losses due to the earthquake were only $8 billion, but that was more than their GDP the previous year. Haiti is the poorest country in the Northern Hemisphere. It's crippled by weak governance, poverty, and lack of resources, and it will take years, if not decades, to recover. In this context, some of the criticism by the media of organizations working there is maybe not fair. Mortality rates and economic losses are used to describe disasters because they're easy to measure. But we mustn't forget that those immediately affected, such as this lady from Sri Lanka, the cost of disasters is felt in terms of loss of family members and friends, their home, personal possessions, income, school days for her children, as well as damage to ecosystems and cultural heritage. Long after the media spotlight has dimmed and aid workers have gone home, families are faced with rebuilding their lives. This is equally true in high-income countries, even though insurance and governments provide a partial safety net. In Christchurch, New Zealand, the loss of life due to a series of earthquakes in 2010-11 was remarkably low, given the severity of ground shaking. However, numerous buildings sustained severe damage, and 2 years on, the centre of the city is dead. Businesses are closed, significant cultural buildings have been demolished, and it will be many years before once again it's a vibrant city. Recent disasters have challenged the view that modern cities are some of the safest places on Earth and highlighted the limitations of humanitarian response. Meanwhile, climate change means that we face an uncertain future. We will need to develop strategies specifically to deal with the possibility of urban disasters, since in 20 years' time, 2/3 of the world's population will live in cities, and it's likely that disasters will become an increasingly urban phenomena due to the high levels of exposure, infrastructure deficits, weak governance, and urban poverty. Many of today's cities are in hazard-prone locations that were originally chosen for their proximity to trade routes, water, or fertile ground. There are over 3,000 coastal cities threatened by sea level rise, including 14 of the largest cities in the world. And according to a recent World Bank report, the number of people living in cities exposed to earthquakes and cyclones may reach 1.5 billion by 2050. The impact of Hurricane Katrina on New Orleans, the extent of the recent floods in Brisbane, Australia, or the devastation caused by the earthquake in Christchurch are all stark reminders that modern cities are not immune to disasters. In fact, due to their locations, many of them are extremely vulnerable. But the majority of urban growth is going to take place in developing countries, primarily Asia and Africa, where already 95% of disaster-related deaths occur. The pace of urbanization poses a major challenge for governments that lack the financial resources, effective governance, or political will to provide the infrastructure and services to support and protect a growing population. The result is unplanned development that's characterized by infrastructure deficits, poor quality buildings, and deteriorating ecosystems, all of which contribute to increased disaster risk. Severe flooding is an annual event in many Asian cities that have grown rapidly over the last few years. Contributory factors include runoff from new developments, destruction of coastal ecosystems, lack of investment in stormwater drainage and inadequate watershed management. And the situation, as here, is often compounded by waste dumped in drainage channels or subsidence caused by unregulated water extraction. At worst, it leads to chronic waterlogging, which creates serious health issues and increases in vector-borne diseases. Those that are most vulnerable are the increasing numbers of people living in slums or informal settlements, without access to basic services and without political voice. It's anticipated that 900 million people will be living in slums by 2020, and frequently these are located on marginal land, such as this, which is highly susceptible to flooding or landslides. But the real challenge in urban areas is complexity. Disasters don't just occur from the direct impact of extreme events on vulnerable groups, but also indirectly due to the disruption of services or loss of essential assets which enable a city to function. Towns and cities comprise a multiplicity of institutions, assets, ecosystems, and infrastructure networks which are mutually interdependent. Cascading failure means that loss of life, damage, and disruption in a localized area can have far-reaching implications, affecting large numbers of people. The blackout in New York in 1977 was the first sign of this. A local lightning strike set in motion a chain of failures. The lack of light made it hard to manually operate substations, examine and repair equipment. Traffic signals, refrigeration, water pumps all ceased to work, and with no power, radio networks shut down, making communication with the public difficult. The city was brought to a standstill. This complexity means that it's much harder to foresee the consequences of hazard events and to respond effectively when they occur. Spatial risk assessments that we're used to are insufficient. Our ability to predict and prevent disasters is limited by our ability to understand and model the dependencies and interdependencies between different parts of the urban system. I have met some engineers who think they can do this, but I beg to differ. Climate change poses a further challenge. Experts predict that climate-related disasters could affect up to 365 million people a year by 2015. That's 40% more than 2 years ago. Climate change mitigation has been the focus of much conversation and international debate, but it only addresses global risk. The implications of climate change at a local level are already being felt, but they're not straightforward, because they are a function not only of the greater frequency and intensity of extreme weather and climate events, but also increased vulnerability due to accumulating stresses such as water scarcity, vector-borne disease, reduced crop yields, and greater exposure to hazards such as sea level rise. The challenge is quantifying the degree of risk. Scientific consensus over future climate scenarios and projections doesn't exist, and will vary considerably depending on our ability globally to reduce greenhouse gas emissions. We're left with the dilemma of being unable to foresee with a meaningful degree of accuracy the severity of weather-related events over the 50 to 100-year lifespan of new infrastructure. This uncertainty challenges traditional risk management practices based on the probability and consequences of particular events occurring, which have underpinned urban planning and infrastructure investments to date. Performance-based criteria may no longer be reliable, and rigid designs based on such criteria risk failure, at worst, catastrophic failure if exceeded. Faced with high levels of complexity and uncertainty, I believe we have limited ability to prevent disasters. We certainly cannot control nature. There are also limited resources to respond as and when disasters occur. Last year, I had the privilege of participating as a senior advisory board member in the Humanitarian Emergency Response Review, HARE, undertaken on behalf of the UK government and chaired by Lord Paddy Ashdown. It concluded that we face a race between the growing size of the humanitarian challenge and our ability to cope, between humanity and catastrophe, and at present, it is not a race, we are winning. Enhancing the status quo by relying on humanitarian response and traditional approaches to risk management is clearly going to be insufficient. A new agenda is required. The HARE review called for greater emphasis to be placed on the effectiveness of humanitarian response, including partnership with the private sector. But it also emphasized resilience, the urgent need to create capacity locally to prepare, withstand, and respond to disasters. Disaster response is not a discrete activity, but one which overlays on the process of development. Its primary purpose is to prevent further loss of life and alleviate suffering. And engineers have played a vital role, providing clean water, sanitation, shelter, and the roads, bridges, and buildings needed to facilitate delivery of food and medical supplies. Considerable credit for this goes to the UK charity REDAR, which was established 30 years ago with the support of this institution. REDAR has facilitated the deployment of hundreds of engineers, including myself, to post-disaster situations, and provided training to thousands of relief workers in order to improve their effectiveness in the field. I think it's laudable that REDAR in recent years has focused its training efforts not on training international responders, but training people living in the countries affected by disasters. Recently, though, the humanitarian agenda has shifted from response to include early recovery. This relies on catalyzing economic activity and rebuilding local infrastructure, but humanitarian agencies don't necessarily have the knowledge, resources, capacity to carry out construction. I was in Sri Lanka for a year immediately after the tsunami, and I then did quite a lot of consultancy work in Aceh and went back several times in the following years. 125,000 houses were built, as well as dozens of schools and health centres. It took 100 humanitarian agencies to build them, and took 3 years. The humanitarian agencies climbed a very steep learning curve. They realized that even construction of simple buildings is far from straightforward, particularly in post-disaster situations where materials and skilled labor are in short supply and where seismic design principles need to be followed. Also, where it's important to involve the community in the process. The most successful programs, without doubt, combined participatory community engagement with technical expertise. Typically, this meant humanitarian agencies employing engineers, or too often architects, but too often they were young and inexperienced, too young and inexperienced to operate effectively alone in what were extremely difficult circumstances. The British Red Cross was an exception, as they partnered with an Indonesian engineering firm from Jakarta, and the benefits of doing so were evident in both the quality of housing seen here and the number of houses they were able to deliver. Partnerships like this, which combine the strengths of humanitarian professionals and the private sector, are essential if limited funds are to be spent effectively and reconstruction is to reduce vulnerability. Unfortunately, the mistakes that were made in Aceh have been repeated in Haiti. Humanitarian response, however, only forms one part of the disaster management cycle. The other half is disaster risk reduction, which is traditionally focused on prevention, preparedness, and tackling the social economic factors that create vulnerability. Infrastructure plays a key role in disaster risk reduction, alongside knowledge and education and early warning systems. Since additional funds are seldom available specifically for reducing disaster risk, it's imperative that disaster risk is integrated in urban planning and infrastructure investments. Building resilience embraces both disaster response and disaster risk reduction. The difference is that it emphasizes local action and the need to build local capacity. The goal is to create resilient communities who understand the risks they face and are able to prepare, withstand, and recover from both catastrophic events and accumulating stresses. But what is resilience? I've used the term several times, and I wonder how many of you really understand it. There is no commonly accepted definition within the disaster world, and few robust case studies to illustrate what it means in practice. Hence, this word cloud, made up of multiple definitions, is the best I could do to illustrate what's an important concept to grasp. It originated from the field of ecology in the 1970s and was originally proposed to describe the ability of complex systems to absorb significant change and disturbance while maintaining the critical relationships that enable the system to function. Inherent in the notion of resilience is the acceptance that disruption will occur and may result in significant change, but that it shouldn't lead to breakdown or catastrophic failure. Traditional disaster risk management focuses on preventing particular events occurring, dikes to avoid flooding, vaccinations to avoid disease, or mitigating the consequences, e.g. seismic design or early warning systems. Building resilience focuses on reducing vulnerability and enhancing the capacities of communities and the qualities of their assets so they can cope with a wide range of disruptive events. It's therefore very different from hazard-specific approaches to disaster risk reduction, which we as engineers normally follow. It's perhaps easiest to understand resilience as a desirable attribute relevant to individuals, communities, businesses, and cities that can only be achieved over time as a result of multiple actions and the accumulation of knowledge which progressively changes behavior, as well as directly reducing risk. Reducing vulnerability and building resilience are important concepts that are implicit in the Hyogo framework for action, which captures international commitment to disaster risk reduction and sets out a global agenda for tackling the growing challenge. The Hyogo midterm evaluation published last year is a very long and very dry document. Notably, engineering, infrastructure, urban are words that are hardly mentioned, other than in the descriptions of the individuals who contributed to the report. However, it does identify 3 areas where further effort is needed. The integration of risk reduction in infrastructure projects is an area that still requires urgent attention. Safe schools and hospitals remain a critical priority, and addressing urban risk, making cities resilient, is a key focus area. Although to date the engineering community has been seen as a peripheral player in international efforts to reduce disaster risk, this clearly needs to change over the next few years. But what does this all mean, really, for engineers? There's no doubt that engineers have made a very significant contribution to reducing risk to date. It's enabled communities to flourish in locations and situations that would otherwise be untenable. But it does question why we haven't played a more central role, either in disaster response and recovery, or formulating policy and strategy, particularly around efforts to address urban risks and to mainstream disaster risk in infrastructure interventions. Our technical expertise and analytical capability is needed, but I wonder sometimes if our perspective is blinkered or our approach too insular, making our contributions harder for others to recognize. The scale of the challenges presented earlier, particularly the increased likelihood of urban disasters, creates an opportunity for a more proactive engagement. I suggest these as 4 principles that could form the starting point for how engineers might consider making a broader contribution. Building on the extensive knowledge and understanding of disaster risk we have developed to date. Firstly, we must embrace a more holistic understanding of risk and recognize the potential which our projects afford in reducing vulnerability. The midterm evaluation of the HERE-GO framework criticized current engineering approaches as being one-dimensional in considering the risk to the project rather than how the project might reconfigure risk territorially. Based on this photo, it's not unreasonable. This is an elevated road in Quy Nhon, Vietnam, which was designed by engineers in an area that frequently experienced 2 to 3 meters of flooding. However, it's created a barrier, which has disrupted natural drainage patterns in the city and caused even worse flooding elsewhere. Engineers are inclined to see disaster risk through a relatively narrow lens related to the performance of physical assets rather than the human consequences of damage and losses. I wonder how many undergraduate degrees, engineering degrees, talk about people rather than just technology. And the insurance industry plays a role in shaping this perspective, as do investors in major infrastructure projects. Performance of physical assets is, of course, really important, but it overlooks the fact that risk may actually be influenced by other socioeconomic or environmental factors, factors which our projects might have the power to influence if we were able to view risk through a wider lens. A school that's appropriately designed will withstand a cyclone or earthquake, but if properly located, it can also act as an emergency community shelter. Its construction provides an opportunity to promote safe construction practices. Of course, the most effective disaster risk reduction initiatives are those that offer short-term development benefits as well as reductions in disaster risk long-term. For example, introducing solid waste management has health benefits in the short term, but it will also reduce the likelihood that drainage channels will be clogged by garbage when there are heavy rains. The concept of Build Back Better, which has become an underlying principle of post-disaster reconstruction, embodies this approach. These photos are taken from my big photo file in Aceh, and I'm very fond of this man on the right, who was very patient as I explained to him again and again and again how he should be refixing the reinforcement. And the poster is an example of how the project was used to introduce better construction practices by building local technical capacity, by transferring the knowledge of the people designing the project. And that poster was put up everywhere in every single village. Reconstruction should make the most of the opportunity to raise awareness of risks within the community and introduce better construction practices, as well as creating safe structures. In urban environments, Build Back Better should also use the window of opportunity afforded by post-disaster funding to formalize tenure and introduce basic services, ideally as part of long-term neighborhood renewal plans developed in consultation with communities as well as governments. In my view, this is what should have happened in Haiti. Unfortunately, it did not. I believe a key reason is that there are few engineers amongst the staff of key decision makers, including UN agencies, the World Bank, and bilateral donors. Nor do these organizations engage engineering firms and consultants in the early stages of recovery and reconstruction when their expertise is most needed. We were invited to develop a rubble removal strategy for Haiti 15 months after the earthquake. Engineers are needed immediately after urban disasters to help identify future pathways that prioritize reinstatement of critical infrastructure and help develop a roadmap for recovery. If we take a more holistic view of risk, we are better placed as engineers to articulate a business case to our clients for investing in disaster risk reduction. I tell this story frequently to people like DFID, who are agonizing about the role of the private sector in disaster risk reduction, in my attempts to explain that you need to create a business case to get the private sector interested. This facility is located in northern Turkey. It belongs to a Japanese car manufacturer who, not surprisingly, had a good understanding of seismic risk. The design for the criteria for the facility, including the equipment and the non-structural elements, exceeded code requirements. Performance requirements were based on incurring minimal damage in a major earthquake. That major earthquake struck in 1999. The facility performed as expected, and operations should have resumed immediately. However, the factory remained closed for several weeks. The reason was that most of the workforce lived in housing which collapsed or was badly damaged. For the Japanese manufacturer, this experience suggests a business case exists for companies to invest in safer housing for its workers, or at least raise awareness of hazards amongst their employees so they can take action themselves. Secondly, we must adopt a systems perspective in the design of urban infrastructure. Spatial risk assessments and approaching risk on a project-by-project basis is insufficient. It ignores the multitude of interactions that ultimately define the consequences of a particular event. The loss of function in a power station might affect water supply and distribution. The closure of a transport hub will have an impact upon the flow of goods and services. On an individual basis, severe damage to a building following a major earthquake event may be acceptable if the occupants can evacuate safely, and that's the principle of life safety design. However, if multiple buildings in the central business district are badly damaged following a major event, the impact on the local economy may be devastating. Systems thinking provides a means to address the dynamic and complex nature of the urban environment and to explore the possibility of cascading failures which can have far-reaching consequences. It's not practical to attempt to model this complexity, though it doesn't prevent us trying to improve the performance of the systems by enhancing their resilience. As I said earlier, resilience is an attribute that relates to the performance of the system as a whole. As such, it can't be measured directly other than by examining changing performance in response to shocks and stresses. Cities that have faced previous disasters, such as Hurricane Katrina or Bangkok, provide a very interesting evidence base of how cities perform under stress. As a proxy, though, it's helpful to consider the characteristics that might describe a resilient system. The 7 shown here are the result of collaborative research, and although generic and qualitative, they are a step towards defining what resilience means in practice. I sometimes feel that they're akin to thinking about sustainability as being about minimizing natural resources and efficiency and minimizing emissions. They give us some clues to help us know what to do. I'm not going to talk about all of them, but I'd like to make 2 key points. Valuing services provided by local and surrounding ecosystems and taking steps to increase their health and stability is critical to resilience. After all, ultimately, that's what the well-being of urban populations depend on. These services are often undervalued, but they perform processes such as flood control, temperature regulation, pollutant filtration, and local food production. They should be considered as green and blue infrastructure and prioritized above gray infrastructure. It's also worth noting that the pursuit of efficiency and the use of minimum resources in the design of infrastructure is at odds with the need to create redundancy and flexibility. Thirdly, we must recognize that appropriate strategies are needed, which reflect local perceptions of risk and the financial and technical resources available. Engineers are perceived as being masters of technology. As our understanding of hazards, structural behavior, and hydrological modeling has improved, our ingenuity has kept pace with increasingly sophisticated technical solutions. Some of the world's tallest and most iconic buildings are located in some of the most hazardous places. Here, the twin towers of St. Francis Shangri-La Place in Manila are the highest towers in the Philippines. They rapidly become icons for the city. They're located near an active fault within a highly seismic area and also vulnerable to typhoon winds. This has all been made possible due to engineering ingenuity and an innovative new damping system which has set new standards for seismic design. Likewise, large-scale sophisticated engineering projects such as the Thames Barrier or the Metropolitan Underground Discharge Tunnel in Tokyo, which is quite extraordinary and includes passive and active systems, are testament to engineering's ingenuity and technical achievement, but they require substantial investment, technical and institutional capacity to implement, operate, and maintain. The floodplain of the Thames estuary is protected from all but the most extreme floods by a system of barriers, floodwalls, and levees valued in excess of £3 billion. Projects like these simply don't represent viable or appropriate solutions in rapidly urbanizing low and middle income countries, where even the introduction of building regulations and land use zoning poses significant challenges. Alternative strategies for reducing disaster risk are needed that reflect these realities but build on our understanding. They need to rely less on technical prowess and effective governance. Strategies that rely on cumulative impact of multiple smaller interventions rather than large one-off projects are infinitely preferable. This is a photo from Ho Chi Minh, which is a low-lying Vietnamese city in the Mekong River Delta. For centuries, it has dealt with water management and flood challenges. It boasts a vast dam, as well as various other defensive measures to protect the city from floodwaters. However, rapid urbanization and climate change have increased its vulnerability to flooding and necessitated new approaches to water management. One solution is to build another dike. Another is a series of integrated interventions relating to both flood management and to water supply. Individually, each of these are on a smaller scale and comprise management of ecosystems as well as physical interventions. Overall, their cumulative impact on risk short-term is comparable to the dike, but long-term affords greater opportunity for future adaptation and, above all, avoids the risk of sudden failure. Additional benefits also include enhancing the natural water systems and increasing the city's green space, which is one of the lowest per capita in the world. There is a need for leaner, efficient solutions like this that work with natural processes rather than against them. And what's missing in cities like these is examples of best practice from other places in the world that they can use as inspiration to come up with their own solutions. Finally, we should encourage a shift to a new culture of safety, which acknowledges uncertainty and recognizes the possibility of failure. Civil engineering, as defined in the ICE's Royal Charter, is the art of directing the great sources of power in nature for the use and convenience of man. Implicit in this statement is an underlying assumption, which is reinforced by public perception, that with sufficient resources and ingenuity, engineers can control nature by designing systems and structures that can withstand or accommodate extreme events. But engineers are not omnipotent. Events where engineered systems or defenses fail are rare, but when they happen, the results can be catastrophic. We have only to look at the breaching of the levees in New Orleans during Hurricane Katrina, or the failure of the reactor cooling system in Fukushima following the tsunami in Japan. The world in which we live is increasingly complex, and the future is more and more uncertain. There is a greater possibility that design criteria will be exceeded. Poor quality materials or workmanship may compromise the design intent, or a scenario will occur that we had not envisaged. Failure is a possibility we need to consider and make appropriate contingency for in our work. If we can't design fail-safe systems, we need to ensure they fail gracefully in a predetermined way, or can be adapted to changing circumstances. Codes of practice are important tools in creating a culture of safety as they formalize the level of risk which society feels is acceptable. As a society's circumstances change and it becomes more developed, what is considered acceptable may also change. We know as a result of the terror attacks of 9/11 that the collapse of an iconic tall building is unacceptable to society in the United States. Yet at present, in many states, there are no specific code requirements that stipulate tall buildings need to be designed to prevent collapse in the most extreme event. Many are designed simply for the minimum life safety criteria in a major event. Code requirements for tall buildings in China and Japan are notably much more onerous, reflecting different perceptions of risk in those societies. Acceptable risk is a matter of public concern and should be debated publicly to ensure society's concerns are addressed and allayed. In the aftermath of a disaster such as Haiti, where no codes existed, acceptable risk is a critical debate, one which could have been used to catalyze awareness and begin to build a culture of safety amongst a diverse group of organizations, governments, donors, non-governmental agencies, contractors. In the absence of a consistent approach, what happened was that individual agencies or their donors were left to determine design standards for the project they're implementing or funding. Typically, they've defaulted to prescriptive criteria based on international codes, which is not necessarily appropriate, particularly for transitional shelters, and overly conservative designs have resulted in wasted resources. Codes and standards are frequently cited as a universal remedy for reducing risk. But code compliancy can also create a moral hazard, isolating individuals and organizations from a true appreciation of the risks associated with occupying floodplains or buildings designed to a particular level of seismic safety. Codes and standards are important, but they are effective only if they are part of a culture of safety that includes engineering education, construction skills, legislation, and enforcement. In many countries, codes and standards do not exist. Even when they do, common building types may not be covered. Indonesia has a very comprehensive seismic code, but it specifically excludes dwellings and single-story buildings. In very many countries, masonry and reinforced concrete has sadly become a ubiquitous form of cheap construction. It's inherently fragile unless properly reinforced, and it's replaced more lightweight vernacular construction traditionally used in houses and schools, displaced the traditions of local good building which have developed over centuries. In seismic areas, it's creating enormous vulnerability. In order to overcome these challenges, greater emphasis needs to be placed on promoting safer construction practices alongside the introduction of codes of practice. It's a strategy that's more likely to ensure that buildings are affordable, culturally acceptable, and can be built, maintained, and adapted by local people. In this, we mustn't overlook vernacular construction. Buildings such as this have performed well in natural disasters in the past. They provide a valuable precedent for future construction, and with minor improvements can be made safer or even safe. The challenge is that there's only empirical rather than scientific evidence to justify their performance, and this lack of understanding leads to fear and neglect of such structures. This is Adaji Diwari House in northern Pakistan. It's a form of timber and masonry infill construction that's evolved over centuries and exists in similar forms in other earthquake-prone countries. But as no code of practice exists which covered this sort of construction, donors wouldn't fund Daji Dewari rebuilding projects in the aftermath of the 2005 Pakistan earthquake. Subsequently, a colleague at work has carried out seismic analysis, which has been verified by physical testing at the University of Peshawar. He's shown that it's possible to model the behavior of traditional Daji Dewari buildings, and that this form of construction can safely withstand forces associated with earthquakes in areas of high seismicity when built properly. To give you an indication of the complexity of the analysis, it takes 8 minutes to run, because every single piece of masonry has to be modeled individually. This is an important step towards developing evidence-based construction guidelines and training materials for this form of construction, which will generate wider acceptance of this type of building. And I believe is an excellent example of how engineers can use our knowledge in new circumstances to significantly reduce disaster risk. The ever-increasing scale and cost of disasters over the last decade is unprecedented. We know that there are parts of the world that are highly exposed and where more and more people are living. We know that climate change will increase the likelihood and severity of extreme events and result in additional stresses. We know that urban areas are expanding rapidly without adequate infrastructure or the benefit of building regulations. We also know that we have considerable learning and knowledge developed over the last 100 years, which could benefit society in many of these vulnerable locations. My journey on disaster risk started in this building in 1991, during the Gulf War, when REDAR called an extraordinary general meeting. Following that, I became a REDAR member, and my first assignment was in northern Tanzania following the Rwandan genocide. Subsequently, I've worked in various places around the world in post-disaster situations. It's left me with one very firm belief. It is the ability of local people to help each other and help themselves that matters most. That is at the core of the resilience agenda. I hope that this lecture will further the debate on response and resilience, and I hope that many of you will engage in that debate, because I firmly believe that we as a profession are critical in reducing vulnerability over the next 20 years. Thank you.
Well, thank you, Joe, for that very stimulating presentation. I'm sure it's stimulated all of our thoughts and generated a few questions. We're now into that part of the proceedings where we're going to invite questions both from the floor and also those posed on the internet, which I will try and master in front of me here. If you're asking a question, please simply indicate. Please wait for the roving mic to come around, otherwise those who are attending via the internet won't be able to hear your question. Please, if you could say your name and affiliation at the same time, and I'll take the first question now, please.
Hello, I'm Margot Meir from Atkins. You've talked about the increasing likelihood and consequences of disasters. So my question is a bit basic. What's your definition of disaster?
There's a disaster. This is about natural disasters, which are caused by natural hazards, which could trigger the event. When you look at the statistics and all the statistics that I quoted, related to specific definitions of disasters, which relate to, I think it's more than 10 people dying, and then more than a certain amount of losses and number of people affected. But there's a statistical basis which is used on the CRED database, which has been a main source for the statistics in this.
Thank you. There's a gentleman here halfway up on this side. Oh. Okay.
Gentleman halfway
No,
up
sorry,
side.
our eyes have caught different people. My sincere apologies for that.
No,
Please ask your question.
My name is Jo McRae from DFID. Thanks very much, Jo, for a fantastic tour d'horizon. You mentioned the example of Haiti, where the likelihood of an earthquake was very low, but the likelihood of hurricanes was very high. Are you confident that we can build resilience to multiple hazards? In other words, are there trade-offs between planning for different kinds of events?
I think there was two problems in Haiti. I think the first was that because there hadn't been an earthquake since 1842, it just wasn't on people's radar. Whereas there'd been severe hurricane events repeatedly over the last 10 years. So that's what everyone was focused on. I found it fascinating when Haiti happened, because everyone was focusing on earthquake risk, but actually the more immediate risk to those affected was the hurricane season coming up. In contrast, when I was working in Aceh, everyone was focusing on tsunami risk, when the major risk in Aceh is actually an earthquake, not the earthquake from the Sunda Trench, which triggered the tsunami, but actually an earthquake from the Sumatran fault, which runs right the way through the center of Sumatra, and where a 9.6 magnitude earthquake is predicted. But in Aceh, 15 months after the tsunami, earthquake risk was not properly on the agenda, because people were just polarized on the risk that they'd immediately faced. And a big part of that is simply because expertise was not consulted. I work for an organization that has some very, very good geohazard specialists. So I can call them up, and very quickly they will provide me a hazard profile of that locality at a level that is detailed, and it's based on historic events as well as maps. And that information isn't feeding in to programs on disaster risk reduction in the ground. One of the things that was very evident in Haiti, for instance, is people were actually building buildings that were meant to be disaster risk, reduced disaster risk, and they had concrete block roofs. So they were masonry buildings with concrete block roofs, and the idea was you could remove the concrete blocks and climb up into the roof when a hurricane came and it flooded. But of course, a very heavy roof like that is the worst thing in an earthquake. So I think the answer is yes, but I think what's not happening at the moment is that the expertise that exists amongst the engineering community isn't reaching the people on the ground who are leading disaster risk reduction programs.
Thank you. There is a gentleman just in front of you here. Thank you.
Will Rogers, now with MWH. Previously, I was lucky enough to work for some 20 years with a consultancy in Southern Africa, where we did a lot of development work. But as such, it was understood that we were paid to do the work. And as such, we were training the local people and were able to put very skilled people onto the work. There is still a feeling that the majority of the work done today is voluntary work. And that means that a lot of people who've got their own needs and their own families are not going to be able, or are maybe unwilling, to give the superb expertise that they have. Is there a chance that we should be thinking of a shift in emphasis on the sort of people that we're going and how we fund the work?
The point you raise is extremely important. I carried out my first assignment when I was 26 years old in northwest Tanzania. However, I'd spent a year already living and working in rural India. So I was and I'd attended 12 radar training courses. So I had the training and some experience to enable me to be effective in that situation. I've always maintained that one of the reasons I can be effective in post-disaster situations is because I come with no personal needs. I come from a stable family, a good job, my company allow me to go and I can offer what I need to provide. But that's unfortunately not true of a lot of people or some people who work in post-disaster situations. And I think there is a friction between the desire for people to go and work in post-disaster situations, and they see it as glamorous sometimes. Redar runs a brilliant course, which is So You Want to Be a Relief Worker, which puts off people. It's not glamorous. It's the hardest work that you will ever do. It's also the most rewarding work you will ever do. But I think the expectation that the only way that agencies can engage technical expertise is through volunteers needs to be challenged. And that is one of the reasons I set up Arup International Development, because pro bono doesn't scale. You can't do more and you can't generate expertise. And one of the major challenges is the high levels of staff turnover in humanitarian agencies. And by creating something like Arup International Development, you've actually created a node of expertise and learning, which I think is really, really important. But equally, I would also like to say that I think it's really important that humanitarian work is done on an at-cost, no-profit basis, because we shouldn't be making money out of other people's suffering. And that includes people who are going out there on paid UK salaries when all their costs are being covered in the country. So I think we can be much more creative about reducing our costs, but I think that we need to move beyond just voluntary effort going into post-disaster response.
I think there's a gentleman in the centre at the back, please.
Yeah, hi Joe, my name is Marcus Oxley with the Global Network for Disaster Reduction. Great presentation, thank you Joe, and I'm finding myself nodding my head with many of the points that you raise. 2 points come to mind. The first one is the feasibility or the challenge of what you propose in terms of holistic approaches, systems thinking. The reality of doing that in an economic system which very much focuses on short-term return on investments. You know, ultimately there is a cost to building resilience, as you've noticed. You know, when you cost optimize on narrow grounds of cost efficiencies, you take out redundancies. The economic system doesn't perhaps value some of the regulating functions of the ecosystems that you mentioned. So first of all, the challenge of our current economic models, which we use, and the second point is related to the issue of equity. Because I think, you know, if we are to have holistic approaches which bring local people into the decision-making processes and builds on the needs, the capacities, the priorities of local people, there's an equity issue here about how you bring people into those decision-making processes. How do you get the information, the access to the resources to those people? And there's a question here about who the development that we're doing currently benefits. Is it genuinely inclusive of the broader population? Or does it perhaps benefit a more narrow group within society? So challenges of economics and challenges of equity there, which I think we need to get to if we're going to adapt the types of strategies that you're recommending.
They're both very big issues, but they are doable. We're currently working, and have been for the last 3 or 4 years, in 10 cities in Asia on a program that's funded by the Rockefeller Foundation. Its purpose is to understand urban resilience and how action at a municipal level can benefit the urban poor and increase their resilience. It's specifically focused at climate change risks. One of the mechanisms that's used there is participatory dialogues, which bring together a wide variety of stakeholders within the city, and therefore generate a much broader perspective on how different communities perceive risk. I should emphasize that the Rockefeller program is an experimental program. It's piloting different approaches in 10 cities in order to try and build an evidence base of what can be done and what does achieve equitable solutions. In terms of the issue of economics, I don't think that having a holistic approach to vulnerability or thinking in systems should necessarily cost more. I think the immediate challenge is actually to shift our way of thinking in that direction. Every time I get involved in this discussion, I go back to sort of 10, 15 years ago when sustainability was emerging on our agenda as engineers, and everyone said sustainability will cost more. It's going to cost more. And actually, we found that after several years of thinking about it, we've actually found in some cases sustainability costs less because using less materials, is cheaper. We're not there yet in terms of creating the economic case for building resilience, but there is a lot of efforts underway globally to try and create that case. And I'm very confident that in a few years' time, there will be evidence and cost-benefit analyses that we can use to justify the directions we're taking.
Thank you. Down here, please.
Paul Jowett, Henry Watt University and the ICE. Well done, Joe. It was a fantastic lecture. In terms of resilience, I suppose it comes in different types. There's physical resilience, there's individual resilience, and organizational resilience. And I won't ask you to say which of those is most important or whatever. But what I would ask you to say is, what is your advice as to what we can do best, i.e. the people in this room, when in a way we're luckily far away and remote from many of the issues you talked about. So in what ways do you think we can best help?
Firstly, resilience does operate at multiple levels. I was talking to someone about this lecture, and they said, that's really interesting. What we do as parents is to try and make our children resilient when they grow up, so they can deal with the ups and downs of life. Within cities, communities need to be resilient, businesses need to be resilient, but they can't be resilient unless the city itself is resilient, because the city is providing the wider enabling environment. I'm not sure I can answer what we can do best, but at this juncture, I think what we just need to do is start thinking about what resilience means. I think it is a different perspective. We in the UK have grown up in an environment where we are very risk averse. We prevent hazards. We shore ourselves up with insurance policies. And we follow that through in the way we approach the design of our buildings. Whereas I think we need to become, as a starting point, much more risk aware. Resilience is a way to address risk. I don't actually believe we're risk aware at the moment. If you live in San Francisco, which is a city with a very, very high seismic hazard, there is nothing that tells you whether the building that you are living in is going to withstand a major event. I assumed that there would be information on buildings like there's information on energy efficiency in this country, so that you could have that information, but it doesn't exist. So being risk aware and creating a higher level of natural disaster risk, I think, is the first point. I also don't think the UK is immune. We have a drought at present. We've had severe flooding. And I anticipate those events are going to get much more frequent over the next 10 to 20 years.
Thank you. I'm going to take two more questions. There's a lot of hands, but in view of the time, I'm going to take the gentleman in the middle here, please.
Yeah, I'm Stephen Young from DFID, and I'm an engineer too. But I'm always struck, that we can come with an engineering analysis to these issues and we can work things through. But then, the challenge is, what are the real kind of political economy issues that are happening that actually prevent these things going forward? And it seems to me that, well, you showed the sort of flooding in the US, now why wasn't that prevented, and they probably knew their dikes were not high enough, but there are bigger political forces going on there. We know that often when there are building codes, there are corruption, other sort of governance failures, if you like, that prevent things moving forward. So I guess part of my question really is actually how we use this information about resilience and building resilience better. Actually, how do we change the governance structures of these countries to actually make the political situation, the decisions that are made there, to really result in resilient communities?
The political economy issues are very real, but they're real not just in developing countries. Arup has carried out city-level seismic risk assessments in 2 separate cities in Asia. One of those cities is Singapore, and the Singaporean government is acting on the outcome of that risk assessment and has put in place a plan over the next 5, 10, 15 years to progressively retrofit or replace buildings that are unsafe. The other Asian city has got stuck and is not sure what to do with the information. So and they're both, they're both very major modern cities. I think in a lot of the cities that we're working in, what the cities are looking for is actually understanding what's possible. I don't think it's for people like ourselves to prejudge what they might or might not be willing to do. And what doesn't exist at the moment is lots and lots and lots of examples of what's being done in different parts of the world and how it builds resilience. In the work that we were doing in Ho Chi Minh, the city was engaged because we brought to them best practice examples from all around the world. And they saw that there were different ways of doing things other than just building a dike. So I think the starting point is actually to show what's possible and then to enable people locally to decide whether it's what they want to do and to create a persuasive case. And I find working with a lot of, there's a gap. I mean, Joanne touched on it earlier. There's people who work in donor organizations, and they are very well versed in the political economy issues. And then there are engineers who are less well versed in those issues, but bring a different perspective and a huge amount of knowledge. At the moment, those conversations are happening in completely different places. And actually, when engineers get engaged, it's quite often downstream in the process with a very prescriptive terms of reference. To give you a very tangible example, there is a program underway, a donor-funded program underway in Malawi to build thousands of schools. And we submitted an expression of interest because I really saw this as an opportunity to build thousands of safe schools in Malawi. And we had worked with the Clinton Hunter Foundation and designed a prototype classroom pro bono to show that you could actually build safe, seismic resilient schools in Malawi for the same amount of money as the government budget. When the request for proposals came through, which was just after Christmas, we didn't respond. And the reason we didn't respond is because we were told that the contracts, the drawings had been done, the specifications had been written, they had been provided to contractors already, and that really what we were being asked to do is simply project manage a process, and there was no scope whatsoever to add any value. Those drawings and those specifications are going to result in thousands of schools in Malawi that cannot withstand an earthquake.
I'm going to take one short question from the gentleman at the back there, who I think was Alexander Pearl. If you just, yes, that's right. On the right-hand side. In the right, that's it. That's it. Yeah. I'm sorry if I've not dealt equitably to the very many other hands that have been here this evening, but I'm sure Joe will field one or two questions outside of the event afterwards if you're still around. Thank you, please.
I'm Dan Epstein from the Useful Simple Project. Just a really quick question. It's interesting you talk about awareness, particularly from around risk and engineering risk. I mean, it seems to me the thing I'm going to take home from this lecture, which is really interesting, Joe, is that actually what you've demonstrated is an awareness not about a particular engineering issue, but about a whole political landscape, a whole cultural landscape when you go into places, a whole ecosystem, a sort of a systems-based understanding, which is what I think we lack. I don't think engineers in the end can do very much on their own. I think this is about, you know, a much greater group of people actually understanding what good development means versus, you know, poor development. Thank you very much.
I think it's a very lovely point to end on, which I totally agree. I think the first step for us as engineers is to recognize that we actually contribute to development and to want to adopt a developmental perspective in our work. And I think that means being more focused on the outcomes of what we do rather than the outputs. We can be delighted by the beautiful buildings that we design or the infrastructure we design, but we also have to, need to be excited about what they achieve. Do they reduce vulnerability? Do they improve the quality of life? And understanding the context of the projects that we are doing is fundamental to understanding what type of outcomes are actually desirable and will benefit society where those projects are located.
Thank you very much, and thank you very much for the questions. And before my closing remarks, I'd just like to take the opportunity of having a captive audience in the room just to remind you all about some up-and-coming events this year. The first of these is the Retrofit Solutions for the Housing Sector 2012, which focuses on the retrofitting Britain's housing stock and preparing for the Green Deal. And this event will be held in Birmingham on the 23rd and 24th of May. The second event is the next in the Duke of Gloucester lecture series entitled The Pit Review 5 Years On, and this will be a question time style panel debate on the topic taking place here on the 31st of May 2012. And then two important conferences for 2013, the 5th International Conference on Forensic Engineering here in London on the 16th and 17th of April, and on the 17th of September to the 20th of September 2013, Coasts, Marine Structures and Breakwaters will be held in Edinburgh. When I was listening, Joe, to your presentation, I thought what I would do is I would write down the key learning points and use those in my closing remarks. And when I got to the end of the third page of A4 here in those on those learning points, I realised that simply wasn't going to work, and it's a demonstration, I think, of the fantastic lecture which you've given this evening. I did, however, pull out 3 challenges, I think, that perhaps we have. The first of these is something around the role that engineers need to play in a changing world. I think the second is around the education and development of those engineers to meet those needs. And thirdly, I think there's a challenge to the institution of civil engineers and the role that it needs to play in fostering and supporting that development. And so I'd like to certainly personally take those challenges away, and certainly in the context of the institution here, think about what that might mean and how we might support some of the very important issues which you've set out in front of us this evening. So on behalf of the Institution of Civil Engineers and everyone here today, Joe, and those both in person and those attending online, I'd really like to thank you for that fantastic presentation and to wish you the best of luck in the rest of the series. Thank you very much. And it's now my great pleasure to invite you all to join us for a drinks reception in the Brunel and Smeaton rooms downstairs immediately following this event. And we hope to welcome you all back to the institution for future events. Thank you very much for coming.